We see a lot of talk around DCIM. What is DCIM? A lot of discussions defining DCIM, when it's right for your organization, when you should deploy it, how you should deploy it. We go to trade shows all the time. The conversation is really around the software side. And in our experience, we've seen customers go through the DCIM selection process. They buy the software, they turn it on, and then they realize it doesn't do anything. And we've seen this many, many times in a lot of data centers, that the software really doesn't do anything unless you have the hardware behind it feeding it the data. And let's see if this works here. All right. So why are these companies doing DCIM? They're doing it, they want that single pane of glass to manage their facility. And it may be one facility, it may be multiple facilities globally, but they want to sit back and look at their data centers through one pane of glass. And so they go for this DCIM initiative. And the goal, that single pane management goal. And what needs to happen for that to actually work is they have to connect thousands of devices and all the data points into the software system. And you're taking that raw data from the devices and turning it into actionable intel. And that's where the step of integration comes in. And integration is something that we think and we see isn't talked about enough. There's not enough emphasis on integration as part of a DCIM deployment. Everybody's looking at dashboards and graphs and access and email alerts and reporting, but nobody's talking about the integration step. And integration is, most of the time, costs as much as the DCIM. So they'll pay, on a large-scale deployment, $500,000, $1 million for a DCIM platform, and then they'll double that on the integration step. And integration is extremely costly. Organizations realize they have thousands of disparate devices across their facilities, and they don't talk to each other. They have to collect that data. They have to bring it up to a point of commonality and get it into the software. So it's time-consuming and very frustrating. We hear the questions all the time: why isn't this easier? Why hasn't somebody figured out a way to make this better, to make this more streamlined? Why can't I turn on my software with all this advanced technology and start getting the data? It takes 6 months, a year, 18 months for the DCIM deployments to be realized. So we have a typical data center here. We have the generators, the gray space, the white space, our little control center here. And in this typical data center, what we find in the DCIM deployments is the power monitoring and power management aspect of the DCIM consumes the most amount of data points. And there's environmentals, there's other devices that are pulled in, but really the majority of the data points is coming from power management. They're managing power from the utility feeds, from the generators, from the electrical room, all the way down to the rack level. Sometimes they're doing it at the server level with metered power strips. So we're looking at literally thousands of these data points, again, have to be brought into the software. And so the data points in this data center would look something like this. And it's not just the sheer number of data points. What happens is you're dealt with something like this, and you see different protocols, you see different manufacturers' devices, different SNMP MIDs, different Modbus maps. Some of them are even pulse technology on some of the older generators, so then you're buying converter boxes to get that data into the software. And so this is really where the issue comes in. So what we found is we said there's some best practices on the device side. So when you're making the device selection to help with that integration process. So I want a little bit about power monitoring, and that's kind of where our specialty is, and where we see a lot of folks have a lot of the headaches is on the power monitoring side. Why there's so many power monitoring devices in the data center? Why are there thousands of these data points? So power monitoring allows you to answer some of these questions around these categories: uptime, capacity planning, cost control, efficiency. These questions come up, and they're solved through power monitoring, but not just monitoring power, taking that data again and turning it into actionable intel with DCIM. And so that data has to be integrated into the software. So let's talk best practices for device selection. The first one is think flexibility. And so we see in data centers 30, 40 different device types just on the power monitoring side, from utility feeds down to the server level, down to the branch circuit, monitoring your rack level power. We see all these different manufacturers, and each power meter does something special. If you're talking multiple facilities, you may have square D panel boards in one, you may have Liebherr PDUs in another, you may have busway in one facility. And so on your global footprint, on your integration step, you're looking at all these different types of devices. And so when we say think flexibility with your device selection, try to minimize the number of devices or the types of devices you're putting in your facility. So let's say in a typical data center, and we back at our data center picture with all those protocols and all those different device types, what if we took 30 different manufacturers' devices and we could cut that down to 4 or 5? And those devices could work on busway, could work on panel boards, could work on PPUs, RPPs. That's going to save you a considerable amount of time and cost in the integration step. And that's exactly what we saw with Verizon Wireless. They came and they said, look, we have retrofit we need to do in some existing facilities. We've got new build projects going. We've got busway. We have panel boards. We have RPPs. We have PDUs. We have a whole wide gamut of different distribution types in our data centers all across the U.S. And they're looking at it and they're saying the integration of all these different device types is costing us as much as our software is, which is costing us more than replacing all these devices is going to cost us if we get onto a platform approach and say the same device that monitors my busway is going to be able to monitor the panel boards and the RPPs and the new build. And so providing that flexible footprint and them choosing that device selection based on the flexibility saved them a large cost on the integration step. So flexibility, the second one is look for multiple protocols. You know, there's too many devices out there in the technology, and I don't know why we see this. Devices will only have serial. Devices don't have Ethernet. They only speak Modbus RTU. They only speak BACnet. And so then you've got this network of conversion and communication networks to get the data from the device into the software. And so the first block diagram, just real simple, is what is typically seen in a lot of data centers. You have the device, you have a converter, whether that's a gateway or some sort of middleware, and then you have your DCIM network where the software can actually read it. If you choose devices that have multiple protocols, you can go directly from device to the DCIM network. And it seems simple, but we still see rooms full of gateways and converters and serial drops and RS-232 and being converted. And that's more equipment to purchase, that's more equipment to manage, that's more integration costs on the DCIM deployment. So we had a company, and I can't say who they are. Darren here would absolutely flip out if I said their name, but we're under pretty strict NDAs with them. But they had data centers, they were co-located, they started building their own data centers. They had an existing BMS system in some of their co-location facilities that only spoke BACnet. It was an Allerton system. And so they wanted a device that could, again, was flexible enough, was their first criteria. They've got a lot of busway, 277, 480 busway, they have some existing PDUs. But the second thing is it had to talk to Allerton, and then also the same device had to be ready to pull into their DCIM initiative that they're rolling out over the next 12 months. And so they chose a device that could work today and could work 12 months for them because of the protocol flexibility. Again, no hardware changes had to be made for them to switch from BACnet to Modbus to SNMP, depending on which software they wanted to pull that into and which way they wanted the DCIM. So again, their DCIM decision wasn't limited by the devices they selected. So we have flexibility, multiple protocols, and the third one is stay adaptable. So adaptability can mean a lot of things. To us, what it means is the adds, moves, and changes that go along in the facility isn't limited by the devices that are monitoring those pieces of equipment. The data center being a very dynamic environment, you have panel boards that may be set up with 20 amp breakers or a certain power configuration today, and then 6 months, 12 months away, then those panel board configurations can be changed. And in a lot of the traditional data centers with legacy equipment, they have to purchase additional equipment to handle those changes. Data centers are doing a big busway push. We see more and more data centers going with busway because it's an adaptable power distribution system. They want power distribution that's flexible for the dynamic environment, yet they still put devices in their data center that aren't adaptable. So every time they make a change, they have a gap in data until they go out and purchase more and then integrate it back into the software. So looking at devices that can handle and be adaptable on the fly and still feed the data regardless of the changes that are made in the facility. The Raging Wire data centers, we partner with them. We've done a lot of monitoring deployments with Raging Wire, and they have a build-back initiative. That's one of their areas. They're pretty advanced with their build-back and the portals they give their customers to manage power that come with the data center facility. They had a customer that said, we don't want your 20 amp feeds. We want 100 amp feeds dropped into our cage with sub-panels. We want to manage our own sub-panels. Well, Raging Wire said, we'll do it. It's the customer, but it created a problem for them to go from 20 amp to 100 amp circuits for their customers. They thought they were going to have to go buy additional hardware, additional meters. Because they chose a device that was adaptable, the hardware itself could be changed from 20 amps to 100 amps on just those circuits, and they had no downtime on the metering hardware. The only cost was the different current transformers to handle the 100 amp circuit, plugged into the same meter that was already installed in the panel board, and they could provide the customer the portal, and they didn't lose any money on their bill-back initiative either. So we have flexibility, the protocols stay adaptable, and then device functionality. And device functionality is kind of wrapped into some of the other best practices, but it goes beyond just flexibility, adaptability, and protocols. It talks about how you interface with the product and how much of the workload the device is sharing versus pushing all that workload onto the software side. And so with legacy devices, they're unintelligent devices. They read data that provide raw data points to the software. So then you have to have a DCI network, DCI servers that can handle a polling rate maybe of every 30 seconds, every 60 seconds they get the data. If the communication network, the DCI network goes down, or the server has a problem, not that servers ever have problems, but if the server had a problem, you'd have a gap in your data because the device is just dumb. It's not providing data unless it's asked for. So device functionality such as onboard alarming, data logging, web interfaces allow you to interact with the product in a way that a lot of other technology is already on that level. I mean, we all have phones that have the advanced interfaces on them, and we're used to that. So devices that are being put in the data center should have a similar interface that allows you to manage it easily. Verizon Wireless, again, another example of a company that needed more functionality. They had a large-scale deployment. They didn't want to use middleware servers, JACEs, to increase their polling time. So they selected a hardware that had greater functionality that could data log at 30 seconds on the device, and then the server only had to pull that data every 20 minutes, every 15 minutes, which saved them from adding to their DCIM network to support a faster polling rate. They didn't need to put in soft chases or different gateways to handle it on the server to pull that data at the rate they needed it. So the last best practice is to think about devices like you would software. So data centers are typically not built out all in one swoop. There's phases, there's different buildings, those buildings get full, you start another data center in another region, there's redundancies that are geographic on these facilities. So the purchasing cycle of data centers are usually spread out over months or years. And sometimes those purchasing decisions change based on the manufacturers of the equipment. So one data center may have Liebherr PDUs, another one may have Schneider PDUs, somebody may be using PDI in another data center, or PDUs and busway mix between your facilities. And what we see a lot of time is data centers select a device that comes with the manufacturer's equipment. So if it's a PDI PDU, they'll use PDI metering. If it's a Liebherr PDU, they use Liebherr metering. If it's a busway, they use whatever the busway manufacturer provides with their product. And you end up with that disparate system with all these different protocols and data points and maps and drivers that have to be written for all this software, for all these hardware devices. So the way DCIM selected is completely different. Is organizations don't select DCIM based on whose equipment they buy. They base DCIM on what's best for their organization. So nobody says, I'm going to use Liebherr's DCIM tool because I use Liebherr's PDUs. They say, I'm going to use Liebherr's PDUs because I like their hardware, and I'm going to go out and I'm going to evaluate all the DCIM products on the market and select the one that's best for our organization. And that's the way the device selection needs to be made in large-scale organizations to prevent the integration nightmare that we typically see. They say, we're going to put in this hardware, these panel boards, this electrical infrastructure, these generators, this switchgear, because that's best for us. And then we're going to separate out that device process and say which devices are best for us, and then which software is best for us. And we see that being very successful. And all our companies, the Company X, Verizon Wireless, Raging Wire, they use that exact format with their devices. I believe one of the customers in using that process reported to us they saved $300,000 on integration because they looked at the devices not on an equipment by equipment basis, but across their whole organization and their whole footprint when they deployed the devices. So Thank you.